First of all, let me introduce myself. I'm Cristian Rasch, for those of you who don't know me. I'm a freelance consultant. I live in Ramos Mejia, Buenos Aires, and you can find me at Twitter at Cristian Rasch. So before I start, let me tell you that this presentation will have more than one meme, so if you have any problems with that, if you're allergic, I invite you to leave the room. So, I wanted to talk about modern concurrency primitives and why they're important and what are the benefits for the average Ruby developer. We've all heard that concurrency is hard and complicated, but how complicated can it be? So, initially, it's going to be very complicated, but only at the beginning. The good news is that concurrency, as any other thing that we learn, either recursive functions or immutable meta structures or any other thing, is just a concept that we can all learn. It's not impossible at all. So, as an icebreaker, let me start by telling you an anecdote that is very funny. Computers will always find a way to amaze us or to annoy us, so we shouldn't let them impact us. So if we start then with the repertoire of Ruby's standard library, we find the famous mutex. I estimate that all of you have had to execute something in multiple cells, and maybe you thought that you would have to use a traffic light. For those of you who never had to use it, the concept is that if we want to increase a variable using many silos, what we could do is map a sequence of threads, and each should iterate n times, and in each iteration, of course, you would synchronize further, but you would implement a counter sleeping so that the processor may execute different threads. So you raise the use of to several threads, and then we put all the threads together, and we see that the results of the counter is indeed 100. So that works, but what's wrong? Basically, the main problem is as follows: synchronization. With a single code line, we are ruining all the benefit of executing things concurrently or in parallel, depending on the implementation of Ruby that we are using. Here, what we are forcing is the processor to remove the thread that is being executed and map it, losing all the benefits of concurrency because they have to do counter switching all the time. So we wondered, why do we have to synchronize? First of all, why? What's the need? There's an old saying that said, let's not share multiple states in multiple threads, but if we're going to do it, we should synchronize the most critical part, that is the shared variable. So to improve the race conditions, those are errors that are very difficult to solve. So now I invite you to play. If you meet 5 local variables, do you know what those are? So this is a trivial example, but it does the same thing. Basically, it maps a number of threads. What each thread does is to increase a variable. And this variable won't be shared. It is mutable, but this is not shared with the threads. We can increase it in every thread without having to synchronize around this increase. And the difference that we have now is that the last sentence of the thread returns the value of this local variable. So when we map the value that is returned by each thread and we add it up, we sum it, and we see that the result is the same all the time without need of synchronization. That's a silly example, but the idea was to show how sometimes by changing the focus of your head shows that there's no need to synchronize, to do things in parallel. So that's what I wanted to show you. It works. To tell you the truth, not everything is wonderful. And sometimes we'll see trying to debug codes that don't operate as well as we want. So some tools that we can use to help us when we have to solve problems. The first stop is the logging issue. All of us, one way or the other, use loggers. In this case, we use a file logger. And what we're going to do is to set an adequate level to the environment where you're executing the app. So in our code, we are going to put some logging sequences to know what's happening. The idea here is to have some visibility. Very often we say that it's not that we have a performance issue, but a problem of visibility. As we don't know what's really happening, we don't realize that the code that we want is inefficient, and think that this happened to everybody at least once. So what this simple sentence tries to do is to do some tracking of what's happening in each thread and seeing the loops. If we see the results and what it logged, basically it's what's happening each time, and this is good for visibility. So my advice is always be appending these loggers to have the information when we need them, to leave tools like log rotate to optimize the space in the disk, and to log as many things as possible, because you never know what you're going to need, using different logging levels depending on the environment where our application runs, and finally make it easily grapable. Now, the interest, because when we need to know why things don't work, we need to be able to access to the information that we logged. Now, let me share with you a dirty little secret that's very useful when developing things. The thread class has an attribute that is abort on exception. What we'll do is that it aborts the process that is being executed if there's an error in any of the threads. And of course, this is a debugging technique, and it gives us a much faster feedback, and we don't have to wait until we put all the threads together to examine whether there were any problems or not. What else can we do to avoid synchronization? Another technique that I run into frequently when I write concurrent is the queues. It's always in the core library of Ruby. This is the queue class. And the good thing about this is that it enables us to put in queue items that we are going to process. Here we're queuing URLs and news, and we define an upper bound of the number of threads that we're going to execute. Here, we need to do this because very often the work that we're going to do, it's not something that we define, but it is determined by an external variable. And if we open multiple threads and more than is really profitable for the time of the processor, we're going to have a poorer performance than we would with a single-threaded application. So a strategy in common basically is to map a number of threads, and what each should do is to take an element from the queue to do some work. In this case is to read a resource in the internet, and then the final step is to bring an item of the queue to continue to process in this cycle the next logging. So what happened after putting all the threads together? What happened here? What's the worst thing that can happen with a code that we just saw? And this is where we start seeing all the problems that you see with these things. Let me tell you just a few stories. I always find it very funny when I tell. We all like, apparently, writing concurrent codes is a challenge, and it seems fun, and it can bring many benefits. To write codes that can work with networks You talk to CCP sockets, that's fun, we do it at school and at work. But the truth is that when we mix the two things and we need to do concurrent code and networks, there are many, many things that can go wrong. One of the things that can go wrong is that in our threads, when there are network connections, they get their Alzheimer and they forget to close them, or they stay there hanging, waiting for the web server, and the thread is there, and you say join, and then he doubts about it and says, well, I'm going to do it someday, and the program never ends, and you hit your head against the wall and say, why is this happening? It shouldn't happen. But I'm a connoisseur of a Ruby standard library, and I'm going to use the Thwaite library to put the threads together, and I'm going to prevent that from happening, but it continues to happen. It's not a solution. It doesn't help much. A form that is more or less good is to specifying a timeout when we put the threads together, and we tell the thread to go with the principal thread. We say you have this time and you need to complete it before that. A little bit way of doing it is logging. And what's good about logging when you're joining? That we're going to know in the end what happened in the thread, whether it finished well or there was an error. Imagine there's an error, that we're speaking of the part where it says log error here. Then we see what the class was of the error, and we look for a start trace all of the entries to see the association of steps that led to this error. And just as good is to log when there are no errors, because we know that everything is working well, and we'll see under what parameters things worked well and under which things don't work. So related to the network code, so we always have to specify timeout. So if you use open URL, you see that you can define a read timeout, and depending on which web server you are hitting, we are going to be able to validate the SSL certificate. So the reason is that the web is basically a mesh of servers where everybody does things, and some there may be fake certificates that will make your blog explode. So what happens with the data structures? In our everyday work, we use hash rise, and we're going to mutate the contents, and we think we think it's perfectly inoffensive, it's harmless, nothing can happen. But let's look at it again. Who says that this code is perfectly safe? Not one of you? Lucas? Who says that it's not safe? All the rest? Who says that it all depends? To tell you the truth, it depends. It depends on the version of Ruby that you have, the Ruby version. If it's Ruby with log, it's perfectly safe. And for Ruby, no. One of the developers of Share Ruby created this gem, thread safe, that is a dropping reverse for our arrays and hash news, so that we can use them with multiple threads, and we won't lose the data when we mount this data structure. Now, apart from this, I wanted to present some of the most popular gems with a longer history in the community that are good to describe concurrent codes. One of them is Thread, that is our companion, whom we entrusted our tasks of writing concurrent codes.
So these are groups of threads, and the way this works is declaring a group of threads, and then when we have work to do. What we're going to do is to delegate this work to the pool. And because the pool has an upper bound, we're going to open up to 4 threads, and 4 things concurrently can be executed. And when the pool has no more threads available, it will block and let the other threads to be released and continues taking the work from the group of threads. And then we shut our pool, and then I finish. And another interesting thing of this gem are the channels. So the channel is a structure that is created in thread, and we assume that we have a string that a thread that will process even numbers. We write I, and one will receive odd, which is arg. And then if someone sends you numbers to this channel, introduce a delay to make it more interesting. Depending on the string that takes the odd or the even numbers, you have one thing or the other, I or arg. That's something else to take into account. Well, processes. A process basically is a thread that we launch and is there listening for and waiting for work to be done. One of these cases, before giving you the example, is the following. Imagine you send an email on Rails or any other web frame you're using. One of the things that was proposed for Rails 4 is to delegate the emails to a thread that is listening in the background, and this is through the following. This is how we could have implemented this. In the example I'm proposing, this is slightly different. It's writing a process where it will always be listening and try to receive messages. So when the messages are received, what is received is stored, is saved. So imagine this sends a model or something that we're sending to the process, and it is done through a serial line. So only one register is received at a time. So when we receive it, it is sent one by one to the destination. And what we do is to send to this process that we created the registers, and these are being processed then. A final component of this gem is the concept of futures, which is also popular in JavaScript. And this is to leave something in the back burner, and then we ask when we're interested in seeing the results. So this behaves similarly. We create a future object, we simulate something in intensive use of CPU through a sleep, and then we return a value. So when we're going to use it, we're going to apply an operator that is like an enclosure, which is the operator of differencing of the object. And the interesting property of this operator is that this depends on the status of the feature. If the feature returned the value, the final value of the execution, then this will respond immediately and nothing will happen. And if it is still calculating things, it is in the middle of the sleep, then it will wait until the value is available and then it will return it. So I wanted to give you some options for future reading on these components so you can continue researching. Tony Arcerius, through the celluloid gem, is the author of the celluloid gem, which is one for actors. This is also a concurrent one. Nothing of this is new. It dates back to the 70s, but it's always up to date in our community. Another gem that is very popular recently is Concurrent Rubyists, gems by Jerry D'Antonio. It has lots of documentation, many things. So it is a place to shop for powerful model concurrency options. It has things that come from Clojure, like agents, things of JavaScript like promises, even things from Java like scheduled and timer tasks. It has supervisors like the ones in celluloid and more options that can be used. So thank you very much. Thank you for listening. And please come and say hello if we meet in the hallway. Thank you very much.